So in this video, we're going to take the Laplace transform of the following initial value problem and solve for y of s is equal to Laplace of y of t. Our y of t is the explicit solution of this differential equation, which is y double prime plus 12 y prime plus 18y is equal to t of t. So we're given initial conditions which are y of 0 is equal to 0, y prime of 0 is equal to 0. And also take note that our t is a periodic function defined by t of t is equal to t for intervals from 0 to 1 half and 1 minus t for intervals from 1 half to 1. Take note that t of t plus 1 is equal to t of t for all t greater than or equal to 0. So that means our period is 1. If this is t plus 2 here, our period would have been 2, but it's not, so that's 1. That means our graph, the graph of our t, which is periodic, keeps on repeating for every after period. So that's just from 1 here, 2 here, 3 here, okay? This is the graph. It's a triangular graph. So that's it. It keeps the graph of t keeps on repeating for every after period. So the first thing we're going to do is to take the Laplace transform of both sides of the equation using linearity. So Laplace of y double prime plus 12y prime plus 18y is equal to Laplace of t of t. So we have an individual formula for here. Take note of that. Laplace of y double prime is equal to s squared y of s minus sy of 0 minus y prime of 0. So the Laplace for our y prime is just s y of s minus y of 0, and Laplace of y is just basically y of s. Take note that if you're in s domain, you use capital letters and you just change it to lowercase letters for the t domain. Okay, so using linearity, we can actually write the left hand side of the equation as Laplace of y double prime plus 12 Laplace of y prime plus 18 Laplace of y, and that is equal to Laplace of our periodic function, which is t of t. Okay, so now let's go plug these in here. Laplace of y double prime is this one, so we use that. S squared y of s minus s y of 0 minus y prime of 0 plus 12. Laplace of y prime is s y of s. Laplace s y of s minus y of 0 plus 18. Laplace of y is just y of s is equal to Laplace of our periodic function, which is t of t. But we can cancel these things out because y of 0 is just 0 from here, and y prime of 0 is just 0. We cancel those out. So we'd be left with s squared y of s plus 12s y of s plus 18 y of s is equal to Laplace of t of t. Okay, so we factor out y of s here. We'll go get s squared plus 12s plus 18 is equal to Laplace of t of t. So divide both sides of the equation by s squared plus 12s plus 18. We're gonna go get our y of s. But it's not complete yet because we still haven't solved for Laplace of our periodic function. And we're gonna solve for that one, and it's a lot of work. Okay, so you see some patterns, right? You see that we already got this part here, our denominator s squared plus 12s plus 18, and we should have our Laplace of t as these terms here. So this should be our Laplace of T of T. So we should get that one, and we're going to solve for that one. So let's go solve for our Laplace of T of T. But remember, our T of T, I'm going to write it here. That's T for this interval. That's half of the period. And this is the other half of the period. Okay. So the formula, let's go for the Laplace transform of T of T. The formula for this one is 1 over 1 minus e to the negative s p, where our p is the period of our t, okay? And integral from 0 to our period, which is 1 in this case, e to the negative st, t of t dt. So we're going to go plug in our p, which is 1, and we'll go get our formula as this one. 1 over 1 minus e to the negative s, because our p is 1, integral from 0 to 1, e to the negative st, t of t dt. But we should split this integral into two, because our t of t is a piecewise function and it has two formulas for different intervals. So let's just go, forget about this first. Let's go solve for this one first. And we'll go denote this one as I from 0, integral from 0 to 1 of e to the negative st, t of t dt. Okay, so we're gonna go split these into half. We're gonna have from 0 to 1 half. Our t of t is t, right? So we'll go write t here, e to the negative st dt. That's for this interval from 0 to 1 half. So that's why we use t, because this is the value or the formula for our function with this, given this interval. Plus the other half is from 1 half to 1, which is our t of t is 1 minus t, e to the negative st dt. Let's go solve for. Okay, so let's go solve for this one first, our first half. Our first half actually is from integral from 0 to 1 half t e to the negative st dt. Let's go use the integration by parts, and we'll let u is equal to t, so that our du is equal to dt, and our dv is e to the negative st dt. So integrating both sides, we will have our v as e to the negative st over negative s. So if you don't know how these works, go watch my other videos because I've explained the integration by parts, but I'm not gonna get into details here. So let's go solve for the indefinite integral first. Let's go forget about the lower and upper limits and consider these indefinite integral first, and we'll just go plug in those limits later after we find the answer. So this is just uv, because I'll just recall it. Integral of u dv is equal to uv minus integral of v du. Okay, you remember that one. So u times v is just t times e to the negative st over negative s minus integral of v, which is this one, so e to the negative st over negative s. Our du is dt. So we can actually make this look like this. Our negative is in here now, negative t e to the negative st over s, and negative times negative, bring the s out of the integral. Negative times negative 1 over s is just positive 1 over s integral of e to the negative st dt. Okay, so now we have negative t e to the negative st over s plus 1 over s. The integral of this is negative st over negative s. So now we got our indefinite integral, and let's go plug the lower and upper limits here, 0 to 1 half. Okay, so let's go plug in t here as 1 half. If t is 1 half, it will be t here is 1/2 as well. E to the negative s over 2, because negative s times 1/2 is negative s over 2 over s. And we'll make this minus s squared. We'll make this minus s squared. S times negative s is minus s squared, right? So 1 over s squared e to the negative s over 2. Okay? Minus, let's go. When t is 0, because we plug in 0 here in our t value, if t is 0, so this part here would be 0 as well. Minus, because this is 1 minus 1 over s squared, e to the 0 is 1 over s squared. You get that? And now we have our first half, which is the integral from 0 to 1/2 t e to the negative st dt, which is, we can bring this down here to bring this down and go let it sit beside s, minus e to the negative s over 2 over 2s. Okay? Minus e to the negative s over 2 over s squared. Minus times minus is plus, so 1 over s squared. So we have our first half. We found our first half. This one. This one here, we found it. And let's go find the other half. And go plug in to get our I later. Let's go find the other half first. Integral from 1/2 to 1 of 1 minus t e to the negative st dt. Again, we're going to use integration by parts. We're going to go let u is equal to 1 minus t. That's why our du is equal to negative dt. This negative here is so important. You should not miss this one. So dv is equal to e to the negative st dt, so that our v is e to the negative st over negative s. Again, integration by parts, and we'll go get t indefinite integral first, and later we'll plug in the lower and upper limits. Is equal to u times v, 1 minus t e to the negative st over negative s, minus v, integral of v du. So this is our v e to the negative st over negative s times negative dt, because du is negative dt. So there's a lot of negative. You should take care of those signs because they're a little bit tricky. 1 minus t e to the negative st over negative s plus, no, it's not plus, it's still negative, because negative times negative is positive. So we just like forget about these things here. We just let this s come out the integral. E to the negative st dt, because negative is negative, right? So that's 1 minus t e to the negative st over negative s minus 1 over s e to the negative st over negative s. That's the integral of this one. So that's 1 minus t e to the negative st over negative s. Negative times negative is just positive s squared, right? E to the negative st. Now we'll go plug in the lower and upper limits, because that's just the indefinite integral, and we'll go plug in those limits. So if t is equal to 1, this part here, 1 minus 1, will become 0. So that's just 0. 1 over s squared. E to the negative s times 1 is e to the negative s. Minus, if t is 1/2, 1 minus t would be 1/2. Easy peasy, right? 1 minus 1/2 is 1/2. E to the negative s times 1/2 is e to the negative s over 2 over negative s plus 1 over s squared e to the negative s over 2. Okay? So that's just e to the negative s over s squared, minus times minus, that's plus. So this is 2s here, minus times plus is minus 1 over s squared e to the negative s over 2. So now we get our other half, and we'll go add it up to the first half to get our I, because we were looking for our I, right? Let's go. We get our second half, and this is our first half. This is our first half, and that was our second half. And we just add these two together, first and second, to get our I. And once we get our I, we can actually plug in it our here our Laplace transform of T. So we won't forget about this one because we were just solving for I, this one. So we won't forget about this one once we actually plug in this whole thing here in our y of s. So there's a lot to consider. So let's just go add this first, the second half. Oh, that's too much. So this is our first half and this is our second half, right? And what if we add those two together? Let's just go add those two together. I is equal to integral of from 0 to 1 half t e to the negative st dt plus from 1 half integral from 1 half to 1 minus t e to the negative st dt. So you just add these two together, and let's go look for what can be cancelled so that we won't bother ourselves from like doing a lot of work. So this here, e to the negative s over 2/2s minus e to the negative s over 2/2s is just 0. So we cancel those out. So that would be left with these two here, these four here, 1, 2, 3, 4. Let's go write this one first. E to the negative s over s squared minus e to the negative s over 2 over s squared minus e to the negative s over 2 over s squared plus 1 over s squared. So take note that these two are the same, similar, so we can actually add these two up. So our I will now become e to the negative s over s squared minus this one here is 2, because there's two of them, negative e to the negative s over 2 over s squared minus e to the negative s over 2 over s squared. That's just two of them. So we write it like this, plus 1 over s squared. Okay, that's our I. This is our I. But take note that we wanted I to get our Laplace of t, right? So that's just the Laplace of t is just the product of this times our I. 1 over 1 minus e to the negative s times our I. And if we have our Laplace, we can now plug it in here to get our y of s. Okay, let's go multiply this. Let's go multiply our I with 1 over 1 minus e to the negative s to get our Laplace of t. Laplace of t is just equal to 1 over 1 minus e to the negative s times our I. So our I is this one. So that's 1 over 1 minus e to the negative s times e to the negative s over s squared minus 2e to the negative s over 2 over s squared plus 1 over s squared. So let's go back with our y of s. Our y of s is actually Laplace of t over t over, what was that again? S squared plus 12s plus 18. S squared plus 12s plus 18. S squared plus 12s plus 18. So basically our y of s is 1 over s squared plus 12s plus 18 times, I just go mix these things here because they have the same denominator. I want this to be joined with this 1 plus e to the negative s, because I want this identical to our inputted answer really. S squared minus over, let's go bring this down, e to the negative s over 2, we'll make it e to the s over 2 times s squared. I'm just making this identical to our inputted answer so that you know that they're clearly identical. And this one, don't forget about this one, 1 over 1 minus e to the negative s. See, we now got our y of s, and I'm gonna show you this answer here is just identical to what that we input in our answer. So this one here is, see, 1 over s squared plus 12s plus 18, correct? 1 plus e to the negative s over s squared is correct. Minus 2 over e to the s over 2 times s squared, correct? Times 1 over 1 minus e to the negative s, which is correct. So that's our answer. That's our answer, and that's correct. Thank you for watching my video. The second half. Oh, that's too much. Okay, that's our I. This is our I. But take note that we wanted I to get our, this answer here is just identical to what that we input in our answer.